All right, everybody, get ready, because today we're going to take a deep dive into the world of microsystem engineering. And let me tell you, this isn't just your everyday engineering gig. We're talking about creating and working with technology so small, it's almost unbelievable. But luckily, we have a pro in the house who can help break it all down for us.
It really is incredible when you think about it, how microsystem engineering brings together all these different areas like mechanics, electronics, even optics. It's like this amazing blend of engineering happening at a level you can barely even see.
I'm already hooked.
Mm.
Now, you've shared some really interesting info from RoleCatcher, a career platform that seems to be all over this field. They mentioned that MEMS are as tiny as a grain of sand, which just blows my mind. Can you paint us a picture of what that actually means and why size is such a big deal here?
So imagine this. We're talking about systems so small they're practically invisible to the naked eye, yet they're packed with all these intricate parts. Microscopic gears, sensors, actuators, all meticulously crafted onto a tiny silicon chip. It's like a miniature factory on a speck of dust. That's essentially what MEMS, or micro-electromechanical systems, are all about. And this incredible miniaturization opens up a world of possibilities, from medical devices that can be implanted in your body to monitor your health in real time, to ultra-sensitive sensors used in everything from your smartphone to space probes.
Okay, that's officially way cooler than I pictured.
Yeah.
The Rollcatcher excerpts also gave us a glimpse into what it's actually like to be a microsystems engineer, and let's just say it's not your typical 9 to 5 engineering job. What makes this career path stand out from the crowd?
I think one of those fascinating things about it is how multidisciplinary it is. As a microsystems engineer, you're not just stuck in one lane. You're constantly drawing on knowledge from all sorts of disciplines like mechanics, electronics, even material science.
So you're not just an engineer, you're like a scientific Swiss Army knife.
That's a great way to put it. It's that fusion of different fields that makes this field so intellectually stimulating. Plus, there's this constant drive for innovation and working with the latest and greatest technology, which keeps things really exciting.
Speaking of keeping things clean, the excerpts mentioned something called clean rooms. That piqued my curiosity. What's the deal with those?
Ah, yes, the mysterious clean rooms. They sound more exotic than they really are. Think of it this way. When you're dealing with components so incredibly small, even a tiny speck of dust can ruin an entire batch. Clean rooms are like high-tech operating rooms, designed to keep the air completely free of even the tiniest particles. It highlights just how much precision and attention to detail are needed in microsystems engineering.
That makes perfect sense. Now, shifting gears a bit, the information also outlined the different career stages in microsystems engineering, and it's pretty cool to see how the role can evolve over time. What are some of the main differences between, let's say, a brand new microsystems engineer and a seasoned veteran, maybe a principal microsystems engineer?
Imagine it as a journey, starting with hands-on technical work and eventually leading to more strategic leadership roles. Early in your career, you might be assisting on projects, running tests, really mastering the art of MEMS fabrication. As you gain more experience, you could be leading complex projects, mentoring junior engineers, maybe even contributing to groundbreaking research and development. And at the highest level, you're not just an engineer anymore, you're a visionary leader guiding the future of MEMS development.
So you're saying someone could start out piecing together microscopic parts and end up leading the charge in inventing some mind-blowing new technology.
That's what's so amazing about this field. There's a clear path for growth, and you never really stop learning.
And RoleCatcher seems to be a big believer in that. They keep talking about how important continuous learning and professional development are in microsystems engineering.
And for good reason, right? The technology in this field is always changing. Something that's cutting edge today might be old news tomorrow. So it's crucial for microsystems engineers to stay ahead of the curve, whether that's by reading research papers, going to industry events, or even just experimenting with new tech in the lab.
It sounds like the kind of career for people who are naturally curious and love to learn.
100%. But it's more than just staying up to date with the tech side of things. Microsystems engineers also have to be adaptable, open to new ideas. Being able to learn quickly and put that knowledge into practice to solve problems, that's key in this line of work.
Makes sense. Now, let's say someone's just starting out, super eager to break into the world of microsystems engineering. What are some practical things they can do to stand out even before they're applying for jobs?
Well, it all comes down to experience. Of course, having a solid educational background is important. Think electrical or mechanical engineering, physics, material science. But it's that hands-on experience that really makes a difference.
RoleCatcher seem to really emphasize that too. They even break down the specific skills and experience that are valuable, right?
They do. And one thing they highlight is the importance of internships. It's one thing to learn about designing MEMS in a classroom, but it's a whole other thing to actually design, build, and test them in the real world.
It's like you can read about baking a cake, but until you actually get your hands dirty in the kitchen, you don't really know what you're doing.
Exactly. Internships give you that hands-on experience so you can use your knowledge, build practical skills, and get a feel for what the job is actually like day to day. And it's not just about the technical stuff either. It's also about making those professional connections and getting your foot in the door.
They mention co-op programs too as another way to get experience. What's the difference between a co-op and an internship?
Think of co-ops as a longer-term, more immersive kind of internship. Usually, you alternate semesters of school with semesters of paid work. So you're really diving deep into the company's research and development processes.
That's amazing. You graduate with actual work experience already.
Yeah. And then there are university research projects. A lot of universities have labs and research groups that are doing cutting-edge work in MEMS development, often on projects with real-world applications. Getting involved in something like that can give students amazing hands-on experience and a chance to make a real impact.
So it's a win-win. You're gaining valuable skills and potentially changing the world at the same time.
Precisely. And since we're talking about making an impact, networking is huge in this field. It's not always about what you know, it's who you know or who you can connect with.
And how do you do that?
Well, industry conferences are great for that.
So it's not just about going to the presentations, it's about actually talking to people.
Exactly. Conferences give you a chance to meet people who could be mentors, future collaborators, or even future employers.
Better have that elevator pitch ready.
Definitely. And don't underestimate online networking either. Platforms like LinkedIn are essential now for connecting with other professionals in your field, joining relevant groups, and just staying on top of what's happening in the industry.
It's like a 247 networking event right at your fingertips.
Precisely.
Yeah.
So yeah, networking is key both in person and online. It's about building those relationships, learning from people who are already doing what you want to do, and opening up opportunities for your career.
So we've talked about getting hands-on experience in networking, but what about the actual work itself? What does a typical day look like for a microsystems engineer?
Well, according to RoleCatcher, one thing that's a constant is problem solving. It's really at the heart of what microsystems engineers do.
Which makes sense when you're dealing with these teeny tiny systems. Things are bound to get complicated.
Exactly. A sensor might stop working, a fabrication process might give you weird results, or you could hit a design challenge you've never even seen before. Being able to look at those problems, figure out what's going on, and come up with creative solutions, that's all part of the job.
So you need to be a technical whiz, but also a bit of a problem-solving ninja.
Exactly. The work can be super detail-oriented, you need to be precise and focused, but it's also unbelievably rewarding. Just imagine designing a device smaller than a hair that could completely change an industry.
That's what I love about this field. It's like engineering meets magic.
Couldn't agree more. But it's important to remember that microsystems engineering isn't usually a solo mission. Collaboration and teamwork are super important, especially since the work is so multidisciplinary.
RoleCatcher made that point too, saying that communication and people skills are just as important as technical know-how.
And for good reason. Microsystems engineers often work in teams with other engineers, scientists, technicians, even business people. So being able to clearly communicate your ideas, listen to what others have to say, and work together to reach a common goal, that's all crucial.
It's like they say, teamwork makes the dream work.
Right. And as you climb the career ladder, those leadership and communication skills become even more important.
Speaking of climbing the ladder, let's talk about career progression. We've touched on the different stages, but what does that upward journey actually look like in terms of responsibilities and what's expected of you?
Well, as you move up from, say, an entry-level engineer to a senior engineer, you're not just dealing with more challenging technical stuff. You're probably mentoring junior engineers too, showing them the ropes and sharing what you've learned along the way.
Like becoming the wise old sage of microsystems engineering, passing the torch to the next generation.
I like that. And at the very top, as a principal microsystems engineer, you're not just an expert anymore. You're a leader, a strategist, even a visionary sometimes. You're setting the direction for a whole team or department, making big decisions about research and development, making sure your team's ready to tackle whatever challenges come up in this constantly evolving field.
That's a big job. but also an incredible opportunity to shape the future.
Absolutely. And it shows how a career in microsystems engineering can give you both intellectual challenges and leadership opportunities.
It's wild to think that someone could go from working with these tiny, tiny parts to leading a team that's shaping the future of technology all in the same field.
It really speaks to the incredible potential and growth in microsystems engineering.
And speaking of growth, RoleCatcher seems really optimistic about the job market for microsystems engineers.
Yeah, and I agree with them.
Yeah.
I think it's a great time to be in this field. We're seeing MEMS tech being used in pretty much every industry you can think of: consumer electronics, healthcare, automotive, aerospace, you name it. And every new application means a need for skilled engineers who can work at that microscale.
So the future is bright for aspiring microsystems engineers.
It really is. And it's not just about filling the jobs that exist now.
Sure.
It's about creating entirely new industries and applications that we haven't even thought of yet.
Wow. So what advice would you give to someone who's just starting out in microsystems engineering, looking to make their mark in this field that's constantly changing?
I'd say the most important thing is to be curious.
Curious.
Yeah, this field is all about pushing the limits, right? And that takes a real thirst for knowledge, a willingness to try new things. Also, be adaptable. Tech changes fast, so you got to be able to learn quickly and apply what you know to new challenges. And lastly, don't give up. Success in this field, just like anything else, takes hard work, dedication, and sticking with it even when things get tough.
Those are some wise words. For our listeners who are feeling inspired and want to learn more, it sounds like RoleCatcher is a great resource.
For sure. They've got tons of information and tools for anyone interested in microsystems engineering, from job descriptions and salary info to interview tips and networking opportunities. It's definitely a good place to start.
Well, we've covered a lot of ground today, from the nuts and bolts of MEMS design and fabrication to the exciting career paths that await those who want to explore this microscopic world.
It's been great.
As we wrap up, is there one big takeaway you want our listeners to remember?
Remember, the future is small, but the possibilities are huge. Microsystems engineering isn't just about building tiny devices. It's about shaping the future of technology, which impacts all of us.
Perfectly said. And to our listeners, thank you so much for joining us on this deep dive. We hope you learned a lot and feel inspired. Until next time, keep exploring, keep learning, and keep dreaming big.